This is a key to section 2.6 part 5, and basically you're dealing with compositions here. So you have to know how to deal with compositions. So first thing you got to remember is your definition of what it means to compose two functions. So you have to remember that f composed with g at x by definition is f of g of x. So remember, composition is where you're taking this function here, putting it inside of f. You're composing f with g. So you're taking g, putting it inside of f. So you see how it looks like g of x is inside of your function f? Okay, so that means f of this. So that's your inside. So that's what so you're putting g inside of f. Okay? So knowing this definition will get you through this particular worksheet. Okay, so in 1a, you want to compose f and g, f with g at 2. Okay, compose f with g at 2. All right, so this is 1a. So f composed with g at 2 means f of g of 2, right? All right, so I got to go off to the side and figure out what g of 2 is. So don't do all that here. It gets a little messy, so you go off to the side. So I got to figure out what g of 2 is. Well, to figure out g of 2, I got to first of all know what the function g of x is. Well, that's here. So g of x is negative 5x plus 2. And so that means that whatever my variable is, I'm going to substitute 2. So I get negative 5 times 2 plus 2. So that's negative 10 plus 2, which is negative 8. All right, now remember, that's just g of 2. So that's this right here. So now I got to come back and take this negative 8, put it inside of function f. So that means f of negative 8 this time. Well, in order to do that now, I got to go to my function f. So that's your function f. So where we see the variable x, you're going to substitute negative 8. So now that becomes, and it's okay if you do it here now, so it becomes 6 minus 3 times negative 8. So that's 6 plus 24, which is 30. So f at g, evaluated at 2, is 30. So f composed with g at 2 is 30. So 30 goes here. All right, b, you have this time f composed with g at negative 3. F composed with g at negative 3. By definition, that's going to be f of g of negative 3. So that's how you write that. Then we got to find g of negative 3 first. G of negative 3. Again, that means I go to my function g, where we see the variable x, I substitute negative 3. So I get negative 5 times negative 3 plus 2. So that's 15 plus 2, which is 17. Now remember, all you found was this now. So now I got to come back and replace this with 17. So now I've got to find f of 17. Okay, so to find f of 17, I go to my function f, and let me go ahead and write f right here. So this is f of x was 6 minus 3x. So I go to my function f, and where we see the variable right here, I substitute 17. So it becomes 6 minus 3 times 17. And so that's 6 minus and then 3 times 17 is going to give you 51. And then 6 minus 51 will give you a negative 45. Okay? So that goes here, negative 45. All right, 1c. All right, in 1c, you want to compose. Now this time, you see how I was composing two functions together at numerical values? I ended up with a numerical value. Here, that's not a numerical value, that's the variable x. I'm going to, just like you did in previous lessons with combinations, you're going to get a variable expression. All right, so in 1c, you want to find f composed with g at x. F composed with g at x. Well, by definition, that's f of g of x. All right, so I got to find g of x first. All right, now I'm going to do this a little bit different than it is here. So remember, to find these, I went off to the side. I don't have to do that anymore because I'm not evaluating a numerical value. So I'm just going to do this approach. So I know g of x. G of x is this function right here. So g of x equals negative 5x. So this is negative 5x plus 2, right? But I got to put that into function f. So that becomes f of this. So this becomes f of g of x is this. So now you got to find this. Well, you had that in previous lessons. So you got to go to your function f. Now this time we're just going to go ahead and write out what function f is. So this is f of x, which is 6 minus 3x. Now remember what that means. That means I go to my function f, and it may help if you circle your variables. So this is the only, on this side, that's the only place I see the variable. And in place of that, I'm going to substitute this binomial. Okay? And so this becomes now 6 minus 3 times, in parentheses, negative 5x plus 2. And then get rid of the parentheses. I get 6 plus 15x minus 6. And then 6 minus 6 is 0, so all you're left with is 15x. All right, so that's 15x. So 1C, the answer is 15x. All right, 1D is this now. So 1D. So 1D, you have G composed with F at x. All right, so here this says F composed with G at x. This is G composed with F at x. So this time, this will be your inside function. So by definition, that means G of F of x, right? Well, I got to find this first. So F of x is this. So this becomes G of 6 minus 3x. So then, remember, now you have to go to your function g and substitute this where we see the variable. So g of x, remember, is this function. And so here's the variable x right here. So in place of that, I'm going to substitute 6 minus 3x. So this becomes negative 5 times, in parentheses, 6 minus 3x, and then plus 2. All right, so negative 5 times your substitution plus 2. Okay? Distributing, I get negative 30 plus 15x. Negative 5 times negative 3x is a positive 15x plus 2. So putting this in descending order, I'm going to get 15x minus 28. 15x minus 28. So that's 1D. So 15x minus 28. All right? Okay, now number 2. Number 2, you have these two new functions now, so those are different functions. All right, so this time you want to find G composed with F at 3 rather. So G composed with F at 3, by definition, is G of F of 3. That's how you read that. So I got to find F of 3 first. Now notice that this is a numerical value, so I'm going to get a real number here. Here you had a variable expression. So let's go off to the side and do some work. So let's figure out what F of 3 is. So F of 3 means I go to my function f, which, remember, it's not the same as number 1. Make sure you use the right one. Is this now. All right, so wherever we see the variable x, I'm going to substitute 3. So I get 5 times 3 plus 1. So that's 15 plus 1, which is 16. Remember, that's just this. So now I got to find g of 16. So g of 16, so this means I go to my function g, which is this right here. Okay, so here's g of x. All right, and where we see the variable x, I'm going to substitute 16. So it becomes 5 minus, replace x with 16. So that's 5 minus 16, which is a negative 11. So number 2, you get negative 11. All right. Now, part B, this time you want to find f composed with g at 3. So the same value, except you're doing, except this time that g is your inside function. So you're taking g, putting inside of f. Here you took f, put inside g. So this is okay, let's look at B. So B is f composed with g at 3. By definition, that means f of g of 3. So I go off to the side, and I got to figure out what g of 3 is. Well, here's g of x. So where we see the variable x, I'm going to substitute 3. So I get 5 minus 3, which is 2. So that becomes f of 2. So then I go to my function f, which is this, and where we see the variable, I substitute 2 this time. So I'm going to get 5 times 2 plus 1. So that's 10 plus 2, which is 11. Okay, so part B is 11. All right. Okay, now part C. Okay, before we do part C, don't think that these are always going to be opposites. Okay, it just happened to be here that those ended up being opposites. So G composed with F at 3, F composed with G at 3 is not always going to be opposites. If you look at this, see those are not opposites. All right, so the opposite of that will be a negative 15x, so that's not what you see here. All right, and now 2C, you have F composed with G at x, which by definition is F of G of x. And so G of x, remember, is this right here. So let's do the work here. So it'll be F of 5 minus x. And so then I go to my function f. I'm going to go ahead and rewrite this. Here's your function f. And so wherever you see the variable x, you're going to substitute 5 minus x. And so then this becomes 5 times 5 minus x plus 1. Distribute, you get 25 minus 5x plus 1. And then that equals negative 5x plus 26. Okay, so negative 5x plus 26. So that is C, negative 5x plus 26. All right, number 3, you have this. Okay, so number 3, you have a quadratic function and a linear function. All right, so same thing, you're going to do the same thing. 3a, you want to find this, G composed with f at negative 1. So by definition, that means G of f of negative 1. So we got to find out f of negative 1 first, the inside first. So f of x is different this time, so this time f of x is this, 4x squared plus 3. So where we see the variable x, I'm going to substitute negative 1. So I get 4 times negative 1 squared plus 3. Notice I put negative 1 in parentheses. Negative 1 times itself is 1. 1 times 4 is 4. And 4 plus 3 is 7. So that becomes, this right here becomes 7. So now I got to find g of 7. So then I go to my function g, which is this. Let me go ahead and write it over. So g of x is this. And so where you see the variable x, I'm going to substitute 7. So I get 3 times 7 minus 2. So that's 21 minus 2, which is 19. So 3a is 19. Okay, part B. All right, part B, you want to find a composition at the variable x. So part B, you want to find f composed with g at x. Okay, by definition, that's going to be f of g of x, right? Okay, so g of x is 3x minus 2. Now you got to find f of 3x minus 2. So then that means you go to your function f, and where we see the variable x, you're going to substitute this. All right, so I'm going to go ahead and rewrite it over here. So basically you're doing this. So you go into your function. This is where I see the variable x. I'm going to substitute this. Now, it's a little bit more work here. So it's going to be 4 times in parentheses 3x minus 2 squared plus 3. All right, now basically, let's just go ahead and multiply this out. So remember that means 3x minus 2 times itself. Now don't forget, you can't distribute first because that's a square. The only time you can distribute is if this exponent is 1. So you have to multiply. You have to multiply this first. You have to square first, exponents, then multiplication. All right, when I follow this, that's going to be 9x squared. The outer and the inner, when combined, will give me negative 12x, and then plus 4. So that goes here. So that's 4 times 9x squared minus 12x plus 4, and then plus 3. And then distributing, I get 36x squared minus 48x plus 16 plus 3. And so it becomes 36x squared minus 48x plus 19. Okay? All right, so that's f composed with g at x. So that's going to be right here, 36x squared minus 48x plus 19. All right, C, you want to find g composed with f at x this time. All right, so by definition, that's going to be g of f of x. So f of x is 4x squared plus 3. So that goes here. So now I got to find g of 4x squared plus 3. So then this says I go to my function g, which is this. And wherever we see the variable x, I'm going to substitute this. All right, so then this becomes 3 times this right here, 4x squared plus 3 minus 2. And then distributing, I get 12x squared plus 9 minus 2, which then gives me 12x squared plus 7. All right, so that's that. So I remember a while ago, I wanted to make note that g composed with f at 3 and then f composed with g at 3, just because those are the same numerical value doesn't always mean they're opposite. It just turned out to be opposites here. So you can see that those are not opposites. Okay? All right. Okay, so that's the key to worksheet 2.6, part